All right, so when are nets helpful? This is Wednesday 422. This is the lesson on nets and surface area. So there's, again, lots of videos on the nets and surface area, but we are going to find surface area using nets. Now, usually the thing that is helpful about nets is helping to think about how many sides, like in the example yesterday, right? I took the shape and I counted up how many of each type of shape there was on the sides, and then then I matched it with a net. And the nice thing about nets is with a net, you can see all the different sides of a three-dimensional shape on a flat surface, and it can help you to piece it out, break it up into pieces to find the surface area. Surface area is different than area because surface area is the area that's on the outside. It's all the areas of all the shapes of a surface. So with a cube, it's actually pretty easy to find surface area. But with a more complicated shape, you might have like the one from yesterday, right? The example that I had yesterday. Let's go back to that actually. It'll be easier to get to it from here. This example that I had yesterday that we were working through, I didn't actually answer it, so it should be the same shape, right? This was this net right here, and you've got 3 rectangles and 2 triangles. So if you were finding the surface area of this, you'd be finding the surface area of the bottom, right? Remember this was like a tent shape, so you'd be finding the area of the bottom, the area of the 2 rectangular sides, and the area of the triangle that's on the front and the back, and you'd be adding all of those pieces together, and that would be the surface area, how much area is on the outside of something. So today we're using the nets to help us to find the surface area. So let's load that back up again. Sorry, I had to. Okie dokie. So check out this cube. Okay, cool. Find the surface area of the cube using its net below. So the nice thing about this cube is this cube only gives us one dimension. It's 4. But a cube, the edges of all cubes are going to be the same. That's the point of cube. So if this cube has if this is 4 right here, everything else is 4. So this would be 4. So then you could find the area of this square right here. 4 times 4. The area of this square is 16. Well, since this is a cube, that means that all the other lengths here, right, these are all going to be 16. This is 16. All these squares are the same. So you have, why is this writing? What's happening? 16. There we go again. 16. Oh, I think it won't let me write down that far. Well, they're all 16. So you have 6 squares, and they're all 16. Oh, you got 6 faces of the square. And 6 times 16 is 96. So this would be 96. And it doesn't give us any units. So I would say units. And the tricky part is it's 96 units squared, not cubed, because even though it is, you notice that right down here it says units squared, because this is a 3-dimensional shape, but we're not finding its volume. We're finding the flat area that covers the outside. And so area is still squared. It's a flat surface. So these would be squared. And that's how you can use a net. So if let's say it had triangles, if it had triangles, then you'd have to find the area of the triangles. So maybe I'll give you an example of that. Let's do one off. Let's just draw one out to the side right here. So let's say that we had a triangular, like a tent shape, like we had yesterday, right? So you have a triangle, and it goes back like this. Okay, and then we can't see that other side, but it's got, this would be like, okay, so there's our poorly drawn triangle. And then let's say it tells us that this is 4, this is 5 over here, and let's say that it gives us a height, like it tells us that this triangle is, let's see, 3, I don't know, 3. Not to scale, just worry about the numbers. So remember that this from the last day, right, was, let's say that this is also, I need another measurement, sorry. Let's say that this is also 5. Okay, so what we have first is we have the bottom, this bottom shape right here. And you could figure out the bottom. Okay, so first you could draw out that bottom. You have the bottom piece there. And attached to the bottom is the right side and the left side. So then you have these other rectangles coming off the side. This is the same shape. And the other side, right? And then attached to the front and the back, you'd have these triangles. Right, if you unfolded, like if you cut it right across here at the top and unfolded it from the top, this is the shape that you'd get. Now you can use the dimensions here in this net to figure out how big all these shapes are, because it says this is 5 by 5. So the bottom is 5 by 5. So that means this is 5 by 5. And then tells us that this is 4, right? So this is 5. And remember we folded out these sides. So this would be 4 here, and this would be 4 across that way. And then the height is 3. This height of the triangle is 3. And you could use all this information to find the area. So since this middle portion is 5, right, 5 times 5, this would be 25. The floor would be 25. He's right, this is 5 times 4, which is 20. So both of these would be 20. These side pieces, 20 and 20. Oops. And then this top would be, we know that the triangle, this is 5, right? This is 5. So the base of the triangle is 5. And the height is 3. And we know that a triangle is 1/2 the base times the height. So 1/2 of the base, which should be 5, times the height is 3. And 5 times 3 is 15. And 15 times a half is 7.5. So this triangle would be 7.5, and this triangle would also be 7.5 because they're the same. And so then you could add them all up. So then 20 plus 25 plus 20, that would be 65, plus the 7.5 plus the 7.5, yeah, it would be 15. So this shape would be 80 units squared, because it's, again, we're finding the area of all these flat pieces. So you can kind of see there's another example of how you could break a shape up and figure out what how to find the surface area of all the pieces.